ideal air standard cycle is shown in the given temperature entropy diagram. The same cycle when represented on PV coordinates takes the form. Here an ideal air standard cycle is given on TS coordinates. There are three processes: 1 to 2, 2 to 3, 3 to 1. Here 1 to 2 is a constant temperature process and 3 to 1 is a constant entropy process. And 2 to 3 we don't know the what type of process it is. So first we'll have to find out these three. How these three process take a form on the PV coordinates. So coming to the PV coordinates, here 1 to 2 is a constant temperature, so it should take some curve form on PV coordinates, and 3 to 1 also should take some curve form on PV coordinates. So see here 1 to 2 is in curve form, and here 1 to 3 to 1 also in a curve form. It might be the one choice. And coming to the 3, here 3 to 1 is a constant volume, but in the original diagram 3 to 1 is a constant entropy process, so it cannot be the answer. And here coming to the here also 3 to 1 is a constant volume, so it cannot be the answer. And here also it is also 3 to 1 is a constant volume process, so it cannot be the answer. So the right answer is A. A is the right option. Which one of the following PVT diagrams correctly represents the ideal gas? So here on y coordinate it is taken as PV, and T is represented on x coordinate. So here for an ideal gas, PV by T is equal to constant, isn't it? So that in the given diagram, here in the A it is a curve and PV by T is not equal to constant, and here it is a curve, but here PV is not directly proportional to T, and here PV is directly proportional to T, and it is constant. PV by T, the slope of the curve is constant, and here D is PV is constant whatever for the temperature, so that D cannot be the answer. So right answer is C. Rolling process: a sheet of 25 mm thickness is rolled to 20 mm thickness. Roller is of diameter 600 mm and it rotates at 100 rpm. So here the roll strip contact length will be, here the roll strip contact length is given by r into theta, where is theta is the angle subtended by the deformed zone at the roller center, and is given by delta t by r, where r is the radius of roller, and here delta t is the change in thickness, and it is equal to 25 minus 20 by r is 300, so which gives a value of 0.129 radians. And now substitute this value in L. So here L is equal to 0.129 into 300, which is equal to 38.72 mm. And in the option, the right option is B. B is the right answer. Which of the following is the time required for taking a complete cut on plate 610 mm into 920 mm? If the cutting speed is 10 meter per minute, the return time to cutting time is 1:4, and the feed is 3 minutes. The clearance at each end is 80 mm. So here the total length of the stroke is given by 610 plus 80 plus 80, so which is equal to 770 mm, and cutting time is equal to 770 into length by cutting speed, so that is here 770 into 770 by cutting speed is 10 meter per minute, that is 10 into 1000 by 60, that is which gives a value of 4.62 seconds. And here the ratio return time to cutting time is given by 1/4. So from these two values, cutting return time is given by 4.62 by 4, which is equal to 1.155 seconds. And here the total time to complete one double stroke, that is both return and cutting strokes, the total time is given by 4.62 plus 1.155, which is equal to 5.77 seconds. And here the total number of double strokes required is, so here the number of double strokes required is 920 by 3 mm, that is the feed rate, so which is equal to 306 nearly, and the total time required to complete the cut is equal to here 5.77 into 306. If we divide it with 60, it gives in minutes, that is 29.45 minutes. So in the options, the right option is A is the right answer. Match list 1 with list 2 and select correct answer using the codes given below the list. Here list 1 consists different types of processes and list 2 consists different types of defects. So here in casting, generally it relates with the defect penetration, so that here P matches with 2, and here in welding the generally the defect occurs is lack of penetration, so that Q 1, and here extrusion, in extrusion center burst is the defect, and in deep drawing flange wrinkles are occurs. So in the option, the right option is A is the right answer. A plate like steel casting with length 300 mm, width 200 mm and thickness 25 mm, using novel research lab method, determine the diameter of the cylindrical riser with h by d is equal to 1. Given from the graph, VR by VC is equal to 0.26 at the shape factor 20, and here shape factor for the given plate is equal to L plus W by T, where L is equal to 300 plus W equal to 200 by T is 25, which gives a value of 20. So here at the shape factor 20, VR by VC is equal to 0.26, and here VC is equal to volume of the cube is equal 300 into 200 into 25, and here volume of the riser is equal 0.26 into this VC, which gives a value of 390 into 10 cube mm cube. But here volume of the riser is equal to 5 by 4 d square L, and here in the given condition take d by h is equal to 1, that means r 5 by 4 d square h, so here d by h is equal to 1, so that it is equal to 5 by 4 d cube, which is equal to 390 into 10 cube, and from this equation we can have d, that is nearly equal to 80 mm. And in the options, so here volume of the cylinder is equal to pi by 4 d square h, and but here d by h is equal to 1, and here it is equal to pi by 4 d cube. So from this equation we can have d is equal to 80 mm, and in the option, the right option is D. D is the right answer. Find the sequence of following jobs by critical ratio technique. Today is day 22 on production control calendar. Here jobs are A, B and C, and date due are 28, 26, 24, and working days remaining are 8, 2, 2. Here the critical ratio is given by CR is equal to due date minus date now, that is today's date on the production calendar, that is, and divided by working days remaining. Here for the A, due date is 28, and date now is 22, and working days remaining is 8. So from this you can have it is 0.75, and for the B, the critical ratio is equal to 2, and for the C, critical ratio is 1.0. So that here the order is A, C, B. So by using critical ratio, the best sequence is A, C, B, and in the options, the right option is B. B is the right answer.